Hello everyone, I am Himanshu Tripathi and I am today going to present a session on IoT based development, and for that IoT topic I am using this ESP32 microcontroller. This is ESP32 Dev Kit V1, and today we'll see that how we can program this ESP32. While programming this ESP32, we are going to use MicroPython as a programming language. Yes, we can program ESP32 while using the Arduino language and Arduino IDE, or we can use ESP32 while using its native development platform, that is ESP-IDF, that is IoT Development Framework. In that ESP-IDF, we used to work with the C or C++ language. But for prototyping, if we are concerned about IoT, then most of the time we will be interested in prototyping quick results for our IoT nodes. So if we are using ESP32 microcontroller as our IoT node, then we can program this device very easily with MicroPython. MicroPython is nothing but the fork of Python language, and we will see that how we can develop our applications using MicroPython on this ESP32 Dev Kit V1. So first of all, I would like to show you on my screen that this is the ESP32 Dev Kit V1 pinout. Let's see the pinout of this device. So this is the pinout of ESP32 Dev Kit V1. So here on this pinout, we can see that we are having different GPIO pins. These GPIO pins are numbered. Please remember that these pins are not numbered into the sequential order. So whatever the pin we may be using, we need to see that which pin is available. Then we can see that all the pins are multiplexed so that they can perform different kind of functions related to communication. Either it may be I2C or SPI communication. I2S communication protocol is also being supported by ESP32. And apart from that communication, we are having some touch sensors here. RTC inputs are also available, and ADC is also available with the GPIO pins. So in this session, we will see that how we can generate digital output using this ESP32 Dev Kit. And for this purpose, we'll be using the onboard LED. Onboard LED is connected with the GPIO pin number 2. And we'll see that how we can program this onboard LED. The next step before we start our development, let's type ESP32 MicroPython, or you can simply go into the micropython.org website .org, and here on this website we will see that what is MicroPython. So MicroPython is a lean and efficient implementation of Python 3. This website is the official resource of MicroPython, and here we can see that it is a lean and efficient implementation of Python 3. So many boards are available nowadays which supports MicroPython, and it is getting a more popular language for IoT based development while we will be using the microcontrollers. So if we are going into the download section, we can see which are the main ports available for the MicroPython, and here ESP32 is listed at this place. And we can see that so many different companies or vendors are providing support for the MicroPython based development on their microcontrollers. So in this session, we are going to work on ESP32. So let's quickly figure it out where the ESP32 is. Here we can see different variants of ESP32. This is the basic variant of ESP32 Room 32 IC. And this is ESP32 C2 variant, and this is C3 variant, C5, C6, and P4, S2, S3. So here almost all kind of variants of ESP32 are being supported by MicroPython. That is a good news. And we are going to work with this ESP32 Room specific IC, and let's click on this link. So here again we can confirm that this is the kind of development board, the dev kit that we are going to use in this session. And here we can see some installation instructions. The first requirement before we are going into the development of MicroPython, the first requirement is we need to flash the MicroPython firmware inside this microcontroller IC. So here, this is the microcontroller ESP32. We need to download or save the firmware inside this IC. So let me tell you that how we can do this thing. This thing can easily be done while using a ESP tool. ESP tool is a package that is available with Python, and if you are interested in ESP tool, you can open your terminal like I am using here my terminal. Okay, so here if I am checking the Python version, Python 3 double dash version, then my terminal is telling me that now it will be visible. So in my system, currently I'm using Python 3.14.3 version. And if I'm checking the pip version, sorry, pip 3 version, most of the systems recognize pip and a few systems recognize pip 3. So pip 26.0 is presently installed in my system. And I have also installed the ESP tool. If you are interested in installing the ESP tool, you can use command pip3 install ESP tool and press enter. So already this ESP tool is being installed in my system, and to check whether the ESP tool is installed and working, we can write the command ESP tool, and if after writing the command ESP tool, this is the command, here I have highlighted that command, and after writing the command, if you are getting these kind of options, that means ESP tool is correctly installed in your system. After installing the ESP32 tool, we need to run few commands, and these are the commands. The first command is we need to write esptool.py. In place of esptool.py, I need to write esptool only. We can replace this esptool.py with esptool, and the command is erase flash. And this command will erase the flash memory of this microcontroller. After erasing the flash memory, we need to install the firmware on ESP32, and for installing the firmware, this might be your go-to command. So let's see quickly that how we can do this thing. Let's open my terminal, and if I'm writing ESP tool, then erase dash flash. Yes, I know that on the documentation it was mentioned erase underscore flash. Here you can see both the commands are working. Erase underscore flash may sometime give you the warning that this command is deprecated. Now the new command is erase dash flash. So we can work with both the commands. So I'm using ESP tool erase flash, and if I'm hitting enter, okay, it's a serial port error something, then this command will work in your system. And after writing this command, you can work with the, you can download this firmware, that is the latest firmware. It is always recommended to download, that is 1.28, and please remember to download the .bin file. So after downloading this bin file, you can basically use this command ESP tool, then baud rate, that is 460800, then write flash is the command. This is a memory location, that is 1000 in hexadecimal. Then this file should be replaced, this bin file should be replaced with the actual file name, which is you are downloading from this link. So after doing these things, ESP tool MicroPython firmware will be correctly installed in your system or in your microcontroller, not in your system. After doing all these things, we can open a editor, that is a Thonny editor. Thonny is an IDE, that is integrated development environment. While using Thonny IDE, we can work with MicroPython based development for ESP32. Before using this Thonny IDE, we need to show that here in the tools, we will go into the options, and in the options, we will select the interpreter. Here, your correct device should be mentioned, that is MicroPython ESP32. and here the USB port with which your device is presently connected, that USB port should be connected with this. Then after selecting these two options, we need to hit OK, and after hitting the OK, here at the bottom of this screen you can see the MicroPython ESP32 is the device, and this is a USB port that I am currently using on my laptop. So this will ensure that you are working with your ESP32. If something is not happening, you can press this stop button, and this stop button will open this REPL, that is the shell of this MicroPython. And here, if you are seeing these three arrows, that means MicroPython is active, and here you can write any command. For example, I am writing help, then modules. So these are the MicroPython modules which are currently installed in my firmware. These are the MicroPython modules which are currently installed. Otherwise, you can run simple Python based commands. 2 plus 2 is equal to 4. Then print hello. This is also working. So this is the place where we can test our single commands, or this is REPL, that means read, evaluate, print and loop. All these four tasks we can perform with this REPL. Here, one more thing, you should ensure that in your device, in your laptop screen, this MicroPython device should be visible. That will indicate that yes, your ESP32 is connected with your laptop. And if you are not able to see these options, you can do one thing. You can go into the view and check on this file option. This file option, then this option will be visible to you. So presently in my MicroPython device, there is one file, that is default boot file, and this boot file is nothing to do. If we'll open that file, we will see that nothing is written here, only some comments are mentioned. Boot file is basically used if we want that during the power on or the power off process, we want to run some script. That script must be written inside this boot.py file. After that, let's close this file and quickly see that how we can work with the GPIO. So here is the new file option, and you can open a new file from here, file menu, then new, and a new untitled file will be open. Let's try to print the hello world first and see whether everything is working or not. So I have written this hello world program or hello world script here, and to run this script, we can press this small green play button icon, or you can use F5 key. After pressing this button, we can see that on our shell, we can see hello world is being printed. That means our development environment is set, and now we are ready to go for any kind of experiments or any kind of scripting on our ESP32 while using MicroPython. So quickly, let me remove this line from here and quickly try to blink the onboard LED. And here in this device, you can see only one LED is presently glowing, that is of red color. This is the power LED. And we are having one more LED here at this point. This is the GPIO LED that is already connected with pin number 2. Let's see that how we can blink that onboard LED using the MicroPython. So for that purpose, I need to import machine module. All the GPIO functions are basically defined inside this machine module. So we need to import machine module if we want to use any peripheral or any GPIO functionality on this ESP32 board. And we need to import one more module for time handling, that is the time. So after importing these two things, machine and time, let's define the LED pin. So this is a variable. LED pin is, let's say that it is pin number 2, and the next thing is we can simply make an object for that LED pin. Let's name that object as LED and then machine dot pin. Inside this machine class, we are using the pin method, and inside this we need to provide two arguments. Here you can see what will be these arguments. The first argument is related to pin number. So I will define pin number in place of pin number, I'll write the LED underscore pin, that is pin number 2. And then the next thing that we need to define is the mode of that GPIO pin. GPIO means general purpose input output pin. So the general purpose input output pin can work in two modes. Either it may be input mode or it may be the output mode. So for LED connections, the pin should be configured into the output mode because LED is an output device. For configuring machine.pin.out. So we have successfully configured the GPIO pin number 2 as an output pin. Now let's try some code as per the Python syntax, and in this code I'm using the indefinite loop while true, and here I'm passing value LED dot value, then inside this I'll pass the value 0, then I'll write time dot sleep. Let's say the LED should sleep for 1 second, or microcontroller should sleep for 1 second. Then LED dot value 1, and then again time dot sleep for 1 second. For debugging purpose, we can include some print statements as well, and let's say print LED is off. I'm considering that my LED will turn off when I'll passing the value 0 at the GPIO pin. It basically depends on the connection of LED, how you are connecting LED with your GPIO. Then after that statement, I can use print then LED is on. Okay, now our main function, our main functionality has been completed. Let's complete this try except block. Except keyboard interrupt. Keyboard interrupt is nothing but control plus C, and here keyboard interrupt, then print script stopped using CTRL plus C, that is the keyboard interrupt, right? Whenever we want to stop this script, we will press Ctrl and C, these both keys on our keyboard, then this script execution is going to be stopped. Okay, I think that our code is complete. Let's quickly see that how this code is behaving. I'm running this script, and here you can see LED is on and off. These messages are being printed on the REPL, and as per the messages, you can see the LED is being blinking. This blue color LED is the GPIO LED that is connected with pin number 2. So this is how we can control the GPIO pins. Let's try to stop this script. If you want to stop this script, then press on this REPL or the shell anywhere, and then press 2 keys, Ctrl and C. After pressing these 2 keys, script is stopped using the Ctrl C, right? So this is a very basic program which shows that how we are controlling the GPIO output with ESP32 microcontroller. Here few points that we need to consider or we need to learn while we are using this script. The first point is that what is LED dot value? LED dot value is a function that is defined under the pin class, pin method of this machine module, and whenever we are passing any value into this, that value is going to be available as an output at that particular pin, right? And if we are not giving any value inside the LED dot value, then it will read the present status of that pin. Let's quickly transform this script so that you can understand. So I'm going to delete this much of a script from here, and again I'm writing LED dot value, and inside this I'm passing LED dot value. So right, and here let me print not as well. Then I am printing the debugging statements. Print LED is on if LED dot value, else I will print LED is off, and let's say that time dot sleep. for 1 second. So this is our new script, and this script is more useful for our case, right? What we are doing, the first thing that this script is going to do is led.value, and please see that inside this bracket, I'm not passing any input argument or any input parameter. That means this script led.value will read the present status of that GPIO pin of this ESP32 dev kit. Whatever the value it will receive, if LED is not on, it is in off state, then definitely the value that microcontroller will receive from this pin is 0, right? And then what we are doing, we are inverting that value with the help of this not keyword. So if we are getting value 0, this not will convert that 0 into the 1, and ultimately inside this led.value, this will become the input parameter. Then led.value is going to be 1. Then if led.value is true, that is 1, then we will print that LED is on. And if LED is already on in the next cycle of this loop, then this led.value is going to be 1. Then this not will convert that 1 into the 0. And finally, we will be passing the input parameter, that is 0, inside this led.value. That means this will turn off the LED, right? And if led.value is not 1, then we will operate this else statement, and inside this else statement, I am writing that LED is off. And finally, after every iteration of LED on and off, we are going to wait for 1 second with the help of this time.sleep. Let's see whether this script is working or not. Again, I am running this script. Here somewhere is let's stop this thing and again run this script. At line number 11, there is an error. Yes, this is the string declaration error. Instead of this single inverted comma, I need to use this double inverted comma because I started this string with double inverted commas. So now the script is clean, and again run, then you can see that LED is on, off, continuously that LED is blinking, right? So what if I am stopping this script when LED is on? So now LED is on, and I'm going to stop this script, right? So script is stopped, and what happened, that LED is still on, right? Why this is happening? Because we are not cleaning the GPIOs before we are exiting from the script. And in embedded systems or in IoT development, it is a mandatory thing. It is always advised. It is not mandatory. It is always advised. If you are using any GPIOs, then if before exiting from that script, please clean all the GPIOs. That is known as a clean exit from that particular script. So for that clean exit, what I can do, I want that default status of LED should remain off. So in place of led.value, I can use led.off without any input, and also I can use led.on. So what these two lines are basically indicating, if I am using led.off, that means I am forcefully passing value 0 to this LED pin, right? And if I am using led.on, that will turn on the LED because I will be passing value 1 at this particular GPIO pin. So if I am looking for the default state, that is the off, so I will add this one line led.off at the end of my script, and again run this script, and you can see the LED is blinking again, and I will stop this script when the LED is on. So I have stopped this script when LED is on, and now you can see that this LED is now off. So this is a very basic session regarding how we can use MicroPython for GPIO control. Specifically in this session, we have seen that how to control the GPIO output with the ESP32 microcontroller using MicroPython as a scripting language. One more problem with this script is that we are using time.sleep. Time.sleep is a blocking delay, and in most of the embedded applications, or if we are dealing with IoT, we need to avoid this blocking delay concept, and we will see in future sessions that how we can avoid this blocking delay concept, blocking delay from our script. so that we can implement the multitasking with our ESP32. Thank you very much for this session.